Hi, this is a Math 3 video on how to use the quadratic formula to solve quadratic equations. There's many reasons why you might want to use the quadratic formula. Number one, maybe the equation is not factorable. Number two, maybe it is factorable, but it's just really ugly and you don't want to try and figure out the factors. Or number three, maybe the quadratic formula just seems like the easiest method out of all the ones we've gone through. All right, so we're going to go through a couple examples of using the quadratic formula for these equations. All right, quick note that all quadratic equations, in this format at least, are in the format of ax squared plus bx plus c. So the numbers corresponding to the variables that go into the formula. All right, let's get started. So we have -7 plus or minus square root of 7 squared minus 4 times a, which is 3, times c, which is -5. Okay, now something to note, always put your b value when it's inside the square root sign that's being squared in parentheses. The reason you do this is because sometimes that b value is going to be negative and it will cause problems if you don't square it correctly. On the bottom, we're going to put 2 times a, which is 2 times 3. Now you're just going to simplify this. You want to simplify the part that's underneath the square root part first. Okay, so if we do 7 squared minus 4 times 3 times -5, we will get 109. So if we rewrite this as -7 plus or minus square root of 109 divided by 6, and we're done. We can stop there. Okay, we'd rather have you not get decimals. We'd rather have it just an expression that you can have there, and that's good enough for us. All right, let's try the next one. So this is an example of something that's just really ugly, and I don't think I'd want to try to factor this if I could. Okay, so do the same steps. So we're going to have this time the 10, since it's negative b, it's going to be positive on the outside, plus or minus square root of, again, putting the b value inside the square root in parentheses before you square it, minus 4 times a, which is 77, times c, which is -247. All over 2 times 77. Now, this is a really ugly problem, so make sure you use your calculator for this. So we have -10 in parentheses squared minus 4 times 77 times -247. And that gives us a very big number. So we have 10 plus or minus square root of 76176, all divided by 2 times 77 is 154. Now, technically, you could probably just leave it like this, but what you should do every time you have these, and we didn't really do it in the last problem because I knew it wasn't going to work, was figure out if that number that's in the square root is a perfect square. So if you put the square root of 76176 into your calculator, you'll find out that it is a perfect square, in fact, and it reduces to 276. Oops, made a mistake. To 276. It's not a square root anymore. Divided by 154. Okay, and the reason we wanted to do this is show you that you can take a factorable quadratic equation and still use the quadratic formula to solve it, but you don't leave it in the radical form. You can keep simplifying it. Even here, this isn't finished. We got to keep going. So you do 10 plus 276, and then divide that by 154. So we'd have 286 divided by 154, and if we reduce that fraction, we will have 13 over 7. Okay, if we do 10 minus 276, we're going to get -266 divided by 154, and that's going to be if we reduce the fraction, negative 19 over 11. So these would be your two fractional answers. Okay, there you go. All right, we've got one more example. Again, you put the b value in. It's going to change sign, so it's going to be positive 12 plus or minus the square root of, again, you're putting that negative number in parentheses under the square root sign, b squared minus 4 times a times c, all over 2 times a. So if we do the calculations for the part that's underneath the radical sign, we've got negative 12 squared minus 4 times 5 times 3. It gives you 84. So we have 12 plus or minus square root of 84 over 10. Now, technically, you can reduce this further by finding perfect squares inside the square root of 84. But at this point in time, where we are in our math journey, we're going to leave it right where it is. So this would be your answer for now. Later on, if we go over reducing radicals, you'd be able to reduce that into something a little bit smaller. And that is the end of this little mini lesson. I wish you luck on using the quadratic formula to solve your quadratic equations.